Hi there everyone, and welcome back to the Maths Tutor exam countdown. So as you can see, this week we are having a look at coordinate geometry, the circle, and I've just put up a screenshot of the pages 18 and 19 of the log tables. So you'll be more familiar with page 18 being for coordinate geometry, the line, but you'll notice today that we use a lot of those formulae in the circle also. And the bottom half of page 19 of the log tables is for coordinate geometry, the circles. So we have our equations of the circles, so the general equation, and the x minus h and y minus k equation, and we have our center and our radius formula for the general equation of a circle also. Okay, so as you can see, I have put two videos in the chat for this week. The first one there is from 2018. It's question 5, and it's looking at a little bit of coordinate geometry, the line, so parallel lines, circles that are touching, and all to do with tangents to those circles also. And the second one is from the 2014 sample paper, and it's a very good question about a circle that has the x and the y axis as a tangent. So for those of you that are not full members, you have access to those two very useful videos, and those of you that are full members, you have access to a range of materials on the TheMathsTutor.ie website also. Okay, so let's get straight into it. We're going to have a look at a couple of exam questions today. So we're going to start with the 2021 question. Paper 2, coordinate geometry of the circle, is always paper 2. And this is question 3 from last year's paper. So the circle K has center 1 minus 2 and chord AB. So as you can see there, the chord is a line that cuts through the circle at 2 points and touches the circle at 2 points. So the distance from A to B is 4 root 3. The point D is the midpoint of the chord as shown below, and we're asked to find the radius of K. So I'm just going to add a radius to this diagram. So I'm going to mark in that line CB, and that's going to be my radius, okay? And what we know is we have a right angle triangle there, okay? Because basically we know from a theorem on our course that the perpendicular from a center bisects the chord. Okay, so the perpendicular line drawn from a center C, so that's going to be this line here, it bisects the chord, and the converse of that theorem is obviously true as well. So because that point D is bisecting that chord AB, the converse of that theorem applies the perpendicular, so that line CD is going to be perpendicular to DB, and because that full length AB is 4 root 3, D is the midpoint, so that length there, DB, is going to be 2 root 3. So if we can figure out, let's just change the colour here, if we can figure out the length from C to D, then we'll have two sides of a right angle triangle, and we can always use Pythagoras to find the third side. So the distance from D to C should be fairly straightforward. We're going to use our distance formula from page 18 of the log tables. So just taking that down, our distance or our length formula from page 18 of the log tables, and the 2 points we're using are C and D, so the center 1 minus 2 and the point D there 3 2. So I'm going to label my points. I have x1 y1 and I have x2 y2, and all I'm doing is subbing straight in to the formula. So that's going to give me the square root of 3 minus 1 all squared plus 2 minus 2, so that'll give me a plus 2 all squared as well. And we can plug that straight into our calculators. That should give me a distance of 2 root 5 for this line here. So we'll mark that in our diagram. And it should be fairly straightforward then to see that we use Pythagoras Theorem to find the distance R, because what we've got is a right angle triangle and we know two of the sides. So Pythagoras Theorem, h² is equal to, sorry about that, a² plus b squared, and subbing in my hypotenuse is r, and my a is, we'll call 2 root 5 our a, and 2 root 3 our b. So you're plugging that straight into your calculator. You've got 2 root 5 squared plus 2 root 3 squared, and that should be giving you 32. So the radius squared is going to be 32. So the radius is going to be the square root of 32, or 4 root 2. Okay, and we've gotten units, I think. No, we've no units in this question, so we don't need to put units in our answer. But just check, give your answer in the form a root b, where a and b are both natural numbers, so positive whole numbers. And sorry, that's exactly what we've done there. It's going to be 4 root 2. So it's no harm to always go back and fill that in your diagram. You may or may not use it in the rest of the question. And in this case, actually, we don't use it because part B is completely unrelated to part A, but no harm to get into that habit anyway. Part B, show that the circles C and S touch externally. So there's my C and there's my S. So I'm just going to draw a rough sketch of a diagram. We have a circle C and we have another circle S. Now, I'm not sure yet which is the smaller or which is the bigger one, but just going to draw a diagram just to give me an idea of what I'm looking at. And I've drawn that they touch externally. That's what we're trying to prove. So we'll remind ourselves that what we need to do is we need to find the radius of C, so we'll call that radius 1. We need to find the radius of S, so we call that radius 2. And we need to show that the radius of 1 and the radius of 2 is equal to D, where D is the distance between their centres. Okay, so we'll start with the circle C, and we're going to work out the centre and the radius of that circle. So let's have a look at it. It's given in, sorry, that's 95 at the end. It's given in general form. So it's given in this form if we look at our log tables on page 19. That's the form that the circle is given in. And we're looking for our centre, which is going to be minus G minus F. So a nice quick way of figuring out the centre when it's given in this form, we take the coefficient of x, we have it, and we change the sign, because remember that's going to be 2g, so half it will give me g, and change the sign will give me minus g. We do the same with the y, so we take the coefficient of y, that's the number in front of the y, we have it, and we change the sign. So that should give me a centre of minus 2, 1 for that first circle C. And for your radius, you're plugging straight into your formula from your log tables. Square root of G squared plus F squared minus C. So that's going to give me the square root of 2 squared, because remember this is minus G, plus minus 1 squared for F, minus C. So this is plus C, so minus C will be plus 95. And that should give me a radius of 10 for that first circle C. And all we're doing is we're doing exactly the same for S. So with S, they've given it to you in a different form. So they've given it in the x minus h squared plus y minus k squared equals r squared form. So it's x minus 7 squared, y minus 13 squared equals 25. And it should be fairly easy to see from that our centre is HK. So in this case, that's just straight from the question, that's 713. And our radius is going to be the square root of 25, which is 5. So our r squared is equal to our 25. So r is the square root of 25, or 5. So it looks like my diagram was fairly accurate. C is the bigger circle with the bigger radius, and S is the smaller circle with the smaller radius. So our job is to find D, the distance between the centres. So I'm going to use my distance formula, just as I did in part A. But this time, here's my x1 and my y1, and here's my x2 and my y2. And obviously it doesn't matter which you label x1, which you label y1. So summing into the formula, we should be getting 7 minus minus 2. That's going to give me 7 plus 2, all squared, plus y2, which is 13, minus y1, which is 1, all squared, and that should give me, I'm just running out of space, so I'll go across here, a distance of 15. And as you guessed, your R1 plus your R2, so let's remind ourselves of where they are. There's my first radius, there's my second radius. That's going to be 10 plus 5, which is also equal to 15. So what you'll notice is we've ended up getting 15 for the distance between the centres, 15 for the radius 1 plus the radius 2. So to finalise, to answer the question, since R1 plus R2 is equal to D, therefore the circles touch, and they touch externally. So not only do they touch, but we've proven, because we've used this formula up here, we've proven that they touch externally in this case. Okay? So again, a 30-mark question. You're probably looking at 10 marks, 10 marks, and 10 marks for each part, but not always. The marking scheme, as you know, can change. So part 2 of B. There are an infinite number of circles which touch circle C externally at the same point that S touches it. Find the coordinates of the centre of one of these circles apart from the circle S. So you cannot use S obviously as your answer. And there's an infinite number of them. You're just looking for one. Okay, doesn't matter which one, they just want you to pick one. So let's just have a look at a diagram again of what we have. We have circle C. So similar to the diagram that we had up here, we've circle C, and we know that circle S touches it at a particular point. We know it touches it externally. So we're looking at that point in there is where it touches it. But what we also know is that we've an infinite number of circles, so loads of them. For example, there's one. There's another one, okay? Just to show you in the different colours, there's an infinite number. I could stay going all day. There's another one, so a much smaller one. But we've an infinite number of circles that are touching that circle at this particular point here, okay, where that circle S touched it. And I'm just going to mark in as well. I have my centre, and all of these circles obviously have a centre as well. But what you'll notice, all of their centres lie on that line. Okay, so they lie on that line, and my drawing isn't excellent. But you can see that the centres, no matter what circle we pick, if I was to draw another one in there, just change the colour very quickly. So if I was to draw another circle in there, again, my diagram isn't great, but you can see that the centre of that circle will also lie somewhere on that line as well. Okay, so our job is to find the equation of this line here. So if we can find the equation of that line, let's call it L, and then we should be able to pick a point on that line, and that will be the centre of one of those circles. And again, I can pick any point on that line. Okay, so for the equation of a line, we need two things. We need, number one, we need a slope, and number two, we need so the second thing we need is a point. So it's going to be nice and easy to find the slope of that line, because we have the slope of the circle C. We have the centre of the circle C, which was minus 2, 1. And because S is one of these circles, we have the centre of that circle, which is 7, 13. So we know that that point 7, 13 is definitely along that blue line L somewhere. So let's label our points, x1, y1, x2 and y2, and we're going to sub into our slope formula, because that's our first job. So again, you see we're using those equations from page 18 a lot. So slope is going to be 13 minus 1, so y2 minus y1, over x2 minus x1, so that's going to be 7 minus minus 2, or 7 plus 2. And that will give me a slope of 4 over 3 for that line. Okay, so obviously my diagram isn't that accurate, but you get the idea. And the second thing we need is a point on the line. So why not use this point here, minus 2, 1, because we've already labelled that as x1 and y1. Second thing we're going to do then is we're going to find the equation of the line, sorry, I'm writing down the wrong formula there. So equation of the line, y minus y1 equals m bracket x minus x1. And all we're doing is just subbing straight into that equation. And that's going to give me y minus, so y1 is 1, equals m, we've just worked it out, is 4 over 3, bracket x minus x1, so that's coming from here, it's x minus minus 2, so that's x plus 2. Simplifying, so I'm going to multiply everything across by 3, that will give me 3y minus 3 equals 4x plus 8, and I'm going to just move everything to one side, so that will give me an equation for L of 4x minus 3y plus 11 equals 0. Okay, and all I'm doing then, I'm just subbing in a value for x, because like we said, there's an infinite number of points on those lines. So there's an infinite number of circles. That means each of those circles have a center, so there's an infinite number of centers. So we're just picking a point. I'm going to pick the point x is equal to 10, and I'm just subbing that in. 4 bracket 10 minus 3y plus 11 equals to 0. That's going to give me 40 minus 3y plus 11 is 0. So that's giving me 51 minus 3y is equal to 0. And solving that equation, we'll end up with 3y is equal to 51. So y is equal to 17. Okay, so the coordinates of the center of one of those circles, well, we've just picked x was 10 and y was 17. And like I said, you might have picked 11 there and you get a corresponding value of y. I'm just picking one of the circles and therefore one of the centers. Okay, so let's have a look at another one. This time we're going to have a look at the 2016 paper. Again, it's paper 2, and this time it was, the circle question was question 2. So what it's asking us to do in the first part is, it's giving us a diagram. The point x has coordinates minus 1, 6, and the slope of that line is 1, 7. Find the equation of xc, so that's that line xc that contains the center, and give your answer in a specific form. So everything at one side, x's, y's constants, and we can have negative numbers there, positive or negative numbers, because z are my integers, so positive and negative whole numbers. So it's an equation of a line, and we know that our equation of line formula, we've just used it in the previous question, y minus y1 equals m bracket x minus x1. Two things that we need a point. So the only point that we have on the line is the point x, that's minus 1, 6, and we need a slope of the line. So we know, we're given that in the question, your slope is 1 over 7. And we're just subbing in. So that's going to be my x1, my y1, my point. And that's going to be my m, my slope. And we're just subbing in. So we're getting y minus 6 equals 1 over 7, bracket x minus minus 1. So that's x plus 1. Be careful with your signs. I'm going to multiply across by 7. So I'm getting 7y minus 42 equals 1x plus 1. So getting rid of the brackets there as well. That is my equation of a line, but just like I did in the previous question, I'm going to bring everything to one side because they're telling me that that's the form I need my answer in. So 1x minus 7y plus 43 equals 0. And check that you've answered the question correctly. That's going to get you your full marks, okay? If you stopped here, again, it depends on the marking scheme, but you're not getting your full 10 marks or your full 5 marks depending on what's going for the question. Okay, you're getting most of them, but you're not getting the full marks. Okay, so remind yourself what that is. That's the equation of this line here. Always kind of bring yourself back and remind yourself exactly what's going on in the question. What am I being asked to do? Part B, C is the centre of a circle S of radius 5, so that's the diagram, and the line L, 3x plus 4y minus 21 is a tangent. So I'm just going to mark that in here. That line is 3x plus 4y minus 21 equals 0, and it passes through the point x as shown. Find the equation of one such circle S. So here it looks like we'll have more than one answer, but we just need to take one of the answers. Okay, so we have a good bit of information here. And essentially, I suppose we're trying to find the equation of a circle. So because we have G and F here, it's obviously going to be in the general equation of a circle. So we're going to need to figure out G, F, and C. So we have 3 variables to figure out, 3 unknowns. So we should be able to come up with basically 3 equations, or equations that will help us to find G, F, and C. So first thing we know is we can see from the diagram that that point minus GF definitely lies on the line XC. And the line XC, we've just worked it out in part A, is x minus 7y plus 43 equals to 0. So that point is definitely on that line. You can clearly see that from the diagram. It's definitely lying on the line. So that should mean that if we sub in minus g everywhere we see an x, minus f everywhere we see a y, it should satisfy the equation. Okay, so that's exactly what we're going to do. Everywhere we see an x, we're replacing it with a minus g. Everywhere we see a y, we're replacing it with a minus f. And everything else stays the very same. So to simplify, we're getting minus g plus 7f plus 43 equals 0. Now, there's not a whole lot I can do with that equation now because we've 2 unknowns and it's only one equation. So we're just going to park that for a second. We're going to highlight it because we'll need it. But we're just going to park it for a second. Okay? We're also given this piece of information here. So we're told that that line is definitely a tangent to the circle. And you can clearly see that the perpendicular distance from the centre to that line is equal to 5, is equal to the radius. And it's that fact that we're going to use to get our second equation, hopefully in G and F. Okay, so perpendicular distance from the centre, so that's minus G minus F, to that line, that tangent line that we're given in part B, that has to equal 5, which is the radius. Because otherwise, if you look back at your diagram, otherwise it wouldn't be a tangent. So it's clear from the diagram and from what they're telling us that that's true. It is a tangent. Okay, so we're going to use our perpendicular distance formula, top of page 19 of your log tables. That comes up quite a bit in the circle and also in the line. And we're just going to sub in. So let's label what we have. Our point is our x1, y1, that's our centre. And our line is our ABC, and it's already in the correct form, so we're good. So subbing in, we're getting the absolute value on the top line of 3 times x1, which is minus g, plus b times y1, which is minus f, plus c, which is minus 21, all in the absolute value signs. And that's all over the square root of a squared plus b squared. So that's going to be 3 squared plus 4 squared. Okay. And subbing in, or simplifying, we also know that that's equal to 5. We know that the distance is definitely equal to 5. Simplifying. Whoops. So simplifying, on the top line, we don't go dropping our absolute value signs, but we're getting minus 3g, minus 4f, minus 21, still in the absolute value signs. That bottom line works out to be 5, and we've got 5 on the right-hand side because we know it's equal to 5, equal to the radius. Okay, so we're going to multiply across by 5. That'll give me absolute value of minus 3g minus 4f minus 21 equals 25. So essentially, that's going to move across there. We're multiplying across by 5, and that gives us 25 on the right-hand side. So what we know about this absolute value sign, let's think about it for a second. Okay, what we know is we know that if we have the absolute value of minus 5, for example, we know that's 5. The absolute value is like the distance. It basically takes the positive of whatever's in it. So if we had the absolute value of x, and I told you that the absolute value of x was 7, for example, well then x could either have been 7, because the absolute value of positive 7 is 7, or x could have been minus 7, because when you put an absolute value sign around it, you get a positive 7 anyway. So remembering that with what we have here, I'm just going to take it up here for a second. Remembering that tells us that if I drop my absolute value signs, so I end up getting minus 3g, minus 4f, minus 21, so I can drop that absolute value sign, okay? That could have been equal to 25, or if we move across, 3g minus 4f minus 21, it could have been equal to minus 25. Because remember, when you put the absolute value signs around it, it's going to make it a plus 25 anyway. So this is where we're expecting two answers, but we only need to take one. So it's completely up to you. Sorry about that. It's completely up to you which one of these you go with. Completely up to you, makes absolutely no difference. And I'm going to go with this one here. Okay, and all we're doing is we're taking that equation and we're simplifying it. So adding 21 to both sides, you'll end up with 3g minus 4f equals 46. Okay, and sorry, that was a minus 3g. Yeah, so that was actually a minus 3g from here. Okay, so that should be a minus 3g as well. I just dropped the minus for some reason when I was carrying it over, but there should still be a minus 3g there. Okay, so remind ourselves what we've now got. We've one equation in g and f, but remind yourself back up here, you had another equation in g and f. So we've two equations. I'm just going to pop them underneath each other. That's minus g plus 7f equals minus 43. Two equations, two unknowns, and we know how to solve. We always solve with our simultaneous equations. So you have the same amount of equations as unknowns, you should be able to solve. Okay, so what I'm going to do so that I can cancel the g's is I'm going to multiply that bottom equation. I'm going to multiply this equation all the way across by minus 3. Or sorry, by 3. So minus 3g minus 4f equals 46. That's just this equation. I'm rewriting it. And we're getting minus 3g plus 21f. And that's going to give you 43 by 3 is 129. And that's a minus 43. So that should have been a minus 129 there. Okay. So we have the same number of g's. They're just the wrong sign. So we're going to multiply across by a minus 1 or change the signs the whole way across. So that will make that a plus, that a minus, and that a plus. And you can see that when you sandwich the two equations together, those two will now cancel and you'll be left with a minus 25f. And we're adding 46 and 129. That gives me 175. So that will tell you that f is minus 7. Okay, and taking that, f is minus 7, you're going to sub back into either of the original equations. It's completely up to you which you do. So I'm just going to take the minus g plus 7f is minus 43. I'm taking that equation, and now I know that f is minus 7. So that's going to be minus g plus 7 times minus 7 equals minus 43. So that's minus g minus 49 is equal to minus 43. That will tell you that minus g is equal to 6. So g is equal to minus 6. Okay, so we have our f, we have our g, and at the start I had said that you needed to find g, f and c. We could go ahead and find c, but I don't think there's really any need here because now that we have g and we have f, we now have the centre. So g is minus 6, so your centre is 6, and f is minus 7, so your centre is 6 and 7. We're looking for the equation of the circle, so we're going to use this formula. X minus h squared plus y minus k squared equals r squared. Because we haven't found c, it's the easiest one to use. And all we're doing is we're subbing in for our h and our k, which is our centre. So that's going to be x minus 6 squared, y minus 7 squared. And remember that your radius is 5. So that's going to be 25 as well for your r squared at the right hand side. Okay, so I ran out of room there, big time, but remember, you can obviously always ask for a little bit extra paper if you've run out of room. Don't try squash things in. Okay, so you can see, even just from doing those two questions there, you can see how prominent the coordinate geometry, the line, those formula from page 18 up here of your log tables, you can see how prominent these formula are. So they're not just limited to coordinate geometry, the line. You're going to see them all over the place in the circle as well. Okay, so guys, hopefully that was of some assistance to you. Hopefully you found that useful. And like I said, you have two very good videos in the chat there of exam questions from 2018 and the 2014 sample paper. Just to have a look at it in your own time and maybe try do the questions alongside them, or try the questions first, maybe might be an idea. Okay, thank you.